Let us practice some calculations on percent composition of an element from a chemical formula. Percent composition is the percent by mass of each element in a formula. For example, if we have water molecule H2O, we will see how much percentage of hydrogen is in there and how much percentage of oxygen is in there in 1 mole of water molecule. That is what is called percent composition. And we can calculate the percent by mass by using the formula percent element equal number of atoms in that compound. For that particular atom, for example, in water molecule, we have 2 hydrogen atoms. So number of atoms times atomic mass of that particular element. For example, hydrogen, we will take the atomic mass of hydrogen from the periodic table divided by the molar mass of the compound. That means we will find the molar mass of H2O by adding the atomic masses of each element times 100. Okay, that's the formula we have to use. So we need a periodic table, a calculator, and get a paper and pencil to practice some questions. Let's see an example to find the percent composition of each element in the compound, which is NaCl. What we have to do first is we have to look at the formula and see how many atoms of each element are in there. We can see that sodium is 1 and chlorine is also 1. And then write the formula and then we will just substitute in the formula. Okay, so first let us see the percentage composition of sodium. So what we have to do is the number of atoms of sodium, which equal 1, and find the atomic mass from the periodic table, which is 22.99 times 100, that is the 100 in the formula, divided by the molar mass of the compound NaCl, which is 22.99 plus 35.453, which equal, when you solve it, you can find it 2299 in the numerator divided by 58.443 in the denominator, which equal 39.34%. And now do the same step for chlorine, and we can see 1 chlorine atom and the molar mass, the average atomic mass of chlorine, we can see that 35.45, okay, 3, I'm missing 3, times 100, that is from the formula, divided by 22.99 plus 35.453. In the denominator is going to be the same, only the numerator will change. Okay, so the numerator we will get 3545. If we are trying to be accurate, 0.3, that will not make big difference in the answer. Okay, so that will equal 60.66%. And now when you add these two percentages, you should get 100 because that is percentage, right? So when you add them, you will get 100 or very close to 100, like in some calculations it will be 99.9 or 99.89, something like that, 100.1, and then you can say that the calculation is correct. Let's see another example, H2O. We will use the same formula and same steps. So what we have to do now, the first step is to find the number of hydrogen atoms in water molecule. We have 2 hydrogen atoms and we are going to substitute in the formula to find the percentage of hydrogen. We will start with the 2 atoms of hydrogen times each hydrogen atom from the periodic table. We can see that 1.008 times 100 divided by the molar mass of water, which we can find by adding the atomic masses of each element. So we have 2 hydrogen atoms, each 1.008 from the periodic table, we can see that, plus for oxygen, we can see that from the right side here, 15.999. When you solve this one, in the numerator, we will have 201.6, and in the denominator, we will have 18.015. When you solve it, we will get 11.19% of hydrogen. And we can find the percentage of oxygen in the same method. So 1 oxygen, we have only 1 oxygen in water molecule. So 1 times 15.999, that is the atomic mass from the periodic table, times 100 divided by the molar mass of water, which is going to be 18.015. So when you solve that one, you can get 88.81 percentage. So when you add them together, we can see that 11.19 plus 88.81 equal 100. So another method is, if there are only two elements, if you know the mass percentage of one of the element, we can actually subtract that one from 100 to get the mass percentage of the other element, right? If there are three, find for two and then subtract 100 minus, add them together and subtract those two elements mass percentage, and then you can get the third one without substituting in the formula. And now you try to find the percentage composition of iron and oxygen in Fe2O3. Pause the video, do the calculation and check your answer. To find the percent composition or mass percentage of iron in Fe2O3, what we will do first, we will write the percentage of iron equal. How many atoms of iron are here? We can see 2, the subscript 2. So 2 times the mass of iron from the periodic table, which is 55.85. That times 100 because it's percentage, divided by the formula mass of this compound or molar mass of this compound. That's going to be 2 times 55.85 for iron, that is from the periodic table, plus 3 because that's a subscript here, 3 times each oxygen is 16 grams from the periodic table. So add them and here multiply and you will get this 111.7 grams divided by 159.7 multiplied by 100, which equals 69.94%. Similar to that, you can find for oxygen. There are 3 oxygens, so 3 times 16 times 100 divided by, you already calculated the molar mass, so that divided by 159.7, that will equal 30.06%. So how will you check that your calculation is correct? Once you have the percentage of each element in the compound, when you add the percentages, it should equal 100. That's the way you are checking. Sometimes it will be a little bit less than 100 or a little bit higher than 100, say for example 99.97 or 100.1, something like that. So then you can say the calculations are correct. Okay, that's one way to check it. And also you can actually find, if you know the mass percentage of iron, you can actually subtract from 100. 100 minus 69.94 will give you the mass percentage of oxygen.